So those last few rules maybe seemed a little easy to work with. That's perfectly fine. We are going to develop the most confusing of them all, and then we're just going to practice using all of them together. So we're going to use the rules that we already know to sort of get a head start on this new rule that we need to learn. I'm going to write these out the long way. So I'm going to grab my pen, and we're going to go 3 to the 5th. Okay, 3 to the 5th is not 3 times 5. And then 3 to the 8th. When I do this, I'm going to use my wonderful fraction rule about canceling. There's a 1, 1, 1, 1, 1. Now there's nothing left to cancel on the numerator. So once that happens, I have to put a 1 there, just as a placeholder. Because 3 times 3 times 3 times 3 times 3 times 1 is still this number. This 1 doesn't change the value in the numerator. It just acts as a placeholder when there's nothing left to write in the numerator. So this is 1 over 3 times 3 times 3, which is really 1 over 3 to the 3rd power. This is small enough we would evaluate it. This is 1 over 27, but I'm interested in what's happening to the exponent. So let's look at our division rule for exponents. This would have been 3 to the 5 minus 8, based on that division rule, which gives me 3 to the negative 3rd power. And so somehow, 3 to the negative 3rd power has to equal 1 over 3 to the 3rd power. In fact, this is how negative exponents were developed. And so it turns out that it's not much of a y, it's just a convention. We have called them such a thing, negative exponents, so that if I have 3 to the negative 3rd power over 1, which is what this is, the 3 to the negative 3rd power is going to say, I don't like being up here in the numerator. I'm going to move down to the denominator, and I'm going to keep a positive exponent. So the negative exponent says, I want to be the reciprocal of what I am. So if we look at this with variables instead, I'm going to have x times x times x times x over 8 of them. I try to say them aloud as I'm writing them on this up. And then I cancel what cancels, and write the 1 that goes on top there. And I wind up with 1 over x to the 4th. And based on our subtraction rule, we should have x to the negative 4th. So x to the negative 4th has to be the same thing as 1 over x to the 4th, which actually matches the rule we just developed quite well. This negative 4 says, I don't like being negative up in the numerator. Please make me my reciprocal. Move me down to the denominator so that I can have a positive exponent. It actually works the other way as well. So we've seen that when I have something to a negative exponent, I really have 1 over that thing to the positive version of that exponent. But if I have 1 over a negative exponent, this also calls for the reciprocal and asks to be up in the numerator with a positive exponent. In other words, the negative exponent wants to switch its spot in the fraction. That's the easiest way I can think about it. This rule takes the most practice, because it's the most confusing. It seems like negative signs just do all sorts of crazy things. So let's just practice. 7 to the negative 2. That's 7 over 1 to the negative 2. And the negative exponent wants to change where it is in the fraction. So this is going to be 1 over 7 to the second power. That's a fairly small number. We'll go 1 over 49. Negative 3 to the negative fourth. That's going to be a 1 over negative 3 to the fourth power. Again, this is a fairly small number. If I have a negative times a negative times a negative times a negative, that's going to be a positive. And 3 to the fourth ends up being 81. Now notice there's not a lot of work to show here. It's just, do you know what negative exponents do or not? That's one of the reasons they're the hardest, is because there's not any work to show. So with something like this, the entire denominator on this expression is 1. And this negative exponent says, I want everything that was in the numerator to go down to the denominator. So this is going to turn into 1 over 2x, where the 2x has an exponent of 1, but I don't need to write that exponent of 1. Lastly, something like 5x to the fourth, or 5x to the negative fourth in this case, I need to remember my order of operations, which are saying it's x to the negative fourth times 5. They both have a denominator of 1 right now, but when I simplify, the 5 doesn't move. It doesn't have an exponent other than that ninja 1 that we used to talk about. The x to the negative fourth, however, says, wait a minute, I don't like where I am in the fraction. I would like to go back be down in the denominator. So when I'm finished, I have a 5 over an x to the fourth. And that would be my final answer. I want us just to practice some more of these, just to get a feel for them. I have x to the third over x to the 10th. It's going to be x to the 3 minus 10. And just to be clear, I'm going to put that over a 1. My placeholder denominator. So this is x to the 3 minus 10 is negative 7 over 1. But that negative 7 says, I don't like where I am. Please, please, give me my reciprocal. Let me be positive. And so I get a 1 over x to the 7th. With my 4s, you might be tempted to cancel them right away and say this is just 1. Unfortunately, you're ignoring the order of operations, which says you must deal with your exponents before you can do anything else. So we need to say this is 4 to the 2 minus 5, which is 4 to the negative third. And remember, these both have denominators of 1. And this negative exponent says I need to be the reciprocal of what I am. This is 1 over 4 to the third power, which is 1 over 64. Notice when my numbers are small, typically less than 10,000, we write them out. We actually evaluate them. If they're any larger than that, we'll just leave them in exponential form. Now, what if I have something like 3 to the negative 1 plus 2 to the negative 2? What can I do with that? You actually need to turn these into their exponential form before you can do anything. So 3 to the negative 1 becomes 1 over 3 to the 1. 2 to the negative 2 becomes 1 over 2 to the 2. So really what I'm looking at here is 1/3 plus 1/4. And now your favorite fraction rules come back. It says I need a common denominator. So I wind up with 4/12 plus 3/12 is 7/12. And the homework is completely within its rights to give you a problem like that. If you know how to translate these two fractions into their fraction form because of their negative exponents, you should be able to add those two fractions together once you see them. Lastly, if I have 1 over y to the negative fourth, this exponent still isn't happy where it is. It says, no, no, please, I don't want to be down here. Please give me my reciprocal. Let me be positive. And so the y to the fourth is just a y to the fourth. Something I want you to be careful about is thinking that these two switch places and the fraction flips. It doesn't. This is technically a 1y to the fourth over 1. There are ninja 1s all over the place here. The y to the fourth is the only thing that's moving. The 1s are staying where they were. Since negative exponents are so tricky, we are going to stop here and give you some time to practice them. The next section that I'm going to record is section 5.2, where we will talk about one more rule of exponents, and then we'll start throwing all of the rules together to simplify everything all at once.